All right. What I want to talk about right now with matrices is still a little bit more about our multiplication, okay? And just kind of in general rules on whether or not we can multiply matrices together. I know we talked multiplication, and you guys clearly, with the problem we started today with, clearly know how to do it, so that's great, okay? I want to talk a couple more things about multiplication because it leads us into the inverse of a matrix, which is what you guys called division, essentially yesterday. Okay. Could I take matrix A and multiply it by matrix C?
Yes.
Yes. Okay. So this is possible. Why?
Because it's columns is 2.
Number of columns in A is 2.
And C is 2.
Number of rows in C is 2. Those match. Okay? How about this?
No.
No. Because
The columns don't match the rows in A.
the columns in C don't match the rows in A. Okay? So that is not possible. Alright? So let's talk a little bit about numbers, and then I'm going to come back here to matrices. Here I'm doing multiplication, right? When I multiply numbers together, 5 times 4, will I get the same answer if I do 4 times 5?
Yes.
Yeah. Does anybody remember what that property is called? Starts with a C. It's the commutative property, which basically says it doesn't matter the order you multiply things together, you're going to get the same answer. So real numbers have the commutative property hold true. A times B would equal B times A for any real number. For matrix multiplication, is that true?
No.
No. If you take matrix A times matrix C, you will definitely not get the same answer if you switch that around. In fact, sometimes it's not even possible to switch it around. Okay? So that's one thing I want you to make sure you understand, is that with matrices, the order that you multiply is very important. Is that clear to everybody? Okay? Could I take matrix B times matrix C?
Yes.
Yes. Could I take matrix C times matrix B?
Yes.
Yes. Do you think I'll get the same answer?
No.
No. Okay? They will be different answers, more than likely. I didn't give you what numbers were inside those, okay? But more than likely, those will be different answers. So therefore, it is important. So that's the biggest thing I want you to understand, is that the order you multiply matrices together is very, very, very important. You have to be careful you're doing them in the correct order. Otherwise, you would potentially get a wrong answer. Okay? Is that all right? Okay. So, next thing I want to talk about is solving an equation. We'll go back to 7th grade here. Well, 6th grade, I taught some of you then too. All right? If I told you to solve this equation, which just involves real numbers, I told you to solve this equation for x, what would you do?
Divide by 3.
You would divide both sides by 3. All right, that's what you were taught. You were trying to get the variable part, the unknown by itself. You clearly can see it's 3 times this variable has to equal 14. So you know this is multiplication. So to undo multiplication, you divide both sides by 3. Okay? If you would like to, if you don't like division, you could also do what to both sides?
Times 1/3.
Multiply both sides by 1/3. Dividing by 3 is the same thing as multiplying by 1/3. You guys are very aware of that. Okay? 1/3 and 3 are what of each other? Reciprocals. Okay, you guys a lot of times will use that word reciprocal. Another word for it would be the multiplicative inverse. That's kind of the fancy word for reciprocal, is multiplicative inverse. 1/3 and 3 are multiplicative inverses. Okay? 2/3 and 3/2 are multiplicative inverses. It's a fancy way of kind of saying reciprocals. What happens when you multiply a number and its multiplicative inverse together? They cancel out and it equals what? 1. Okay? It equals 1. When you take a number and you multiply by its multiplicative inverse, you get the number 1, which then 1 times that variable is just that variable. So it's getting that variable by itself, right? So, if you take something times its multiplicative inverse, it essentially cancels each other out or gets the number 1, right? Okay? I want you to keep that idea in mind for what we're eventually going to do here. Okay? So, anything times its multiplicative inverse cancels itself out. What you will eventually solve is some sort of equation that may look like this. So I have some matrix here times another matrix. We got to figure out what that matrix is. And that's going to equal this matrix. Similar to what we did at the start of class today, where I gave you a 2 by 2, I had you multiply it by a 2 by 1, and then you guys got the 2 by 1 answer, right? And now we're switching around. Instead of me giving you these two, I'm giving you the answer. You got to figure out what this had to be multiplied by to equal this one. Okay? So let me go through the rationale of what we'll do to find this out. I'm going to call this matrix here, I'm going to call that matrix A. Okay? Matrix A is being multiplied by matrix X, and that will equal, I'll call this one matrix B. Okay? If you have to solve for matrix X, and it's not possible to divide by matrices, what would you have to do to both sides of the equal sign to get matrix X by itself? Multiply by the inverse, the multiplicative inverse of matrix A. Okay? Let me go back here. 1/3 and 3 are multiplicative inverses. 1/3 is the same as 3 to the negative 1 power, right? 3 to the negative 1 is 1/3. Okay? In fact, if you raise anything to the negative 1 power, aren't you finding its multiplicative inverse? So that's kind of the notation that we'll use. So to solve this for x, I need to multiply by the inverse. Now, because order is important, I need to left multiplication both sides by the inverse.
What does that mean?
Well, what I mean is I can't just put times A inverse on the right side of it.
Oh,
Because remember how I talked about how order of multiplication was important?
yeah.
So if I multiply the left side of this equation by A inverse, I have to multiply the left side of this part of the equation by A inverse as well. What happens when we take a matrix and we multiply it by its inverse? What happens when we take a number and we multiply it by its inverse? Cancels out and essentially becomes the number 1, right? Okay? And I'll show you what it will actually equal here in a moment. Okay? But really, they cancel each other out, and this matrix X will equal whatever A inverse times B would equal. So this is kind of our end goal here, is trying to solve these matrix equations using inverses. That's what our end goal is going to be here today. How do you do inverses? That's going to be the first thing I'm going to teach you. But I wanted to give you what we were shooting for, why I'm teaching you inverses in the beginning, so that way you have an idea of where we're going with this. Okay? Because unfortunately finding inverses is not as simple as just doing the reciprocal. Alright? So everybody good with kind of where we're headed with this here today? While we're doing inverses? Okay? Alright. We'll work with 2 by 2 because those are the only size matrices you'll have to do anything by hand. The rest you'll be able to use graphing calculators to help you do that. Okay? So 2 by 2, determinants and inverses. Okay? Determinants. N-A-N-E-S. Sorry about that. 2 by 2 determinants and inverses. So first of all, determinant of a 2 by 2. So let's say we have some matrix A with elements A, B, C, D in it. The determinant of matrix A, that's the shorthand, the notation you'll see for determinant is DET. You'll also see that on your graphing calculator as well. The determinant of matrix A can be found by taking this diagonal product minus this diagonal product. So AD minus BC. Then the inverse of a 2 by 2 matrix can be found so again, if this is matrix A, the inverse of matrix A is 1 over the determinant of A times A and D switch spots, B and C switch signs.
Signs?
Become opposite.
We just have to remember this?
Yeah.
Matrices are so easy.
Relaxing.
I actually like this.
This is really cool.
It makes it like keep it like it's not even like easy to follow a pattern.
No, you didn't memorize
It's like
it.
diagonal, this, that.
What now?
Can you explain it?
So,
I don't understand visual math behind it. I just sort of know what matrices go through these different signs.
in order to find the inverse, okay, I need to first figure out what the determinant of matrix A is, and this is the math you will do there. Okay, you'll just take A times D, you'll multiply those values together, minus B times C, you'll multiply those values together. Okay, that'll help you find the determinant of matrix A.
What is
Well, then you subtract
Okay.
those and that's
Well, I could work backwards through kind of a proof to show you how we get to here.
Okay, I don't care that
And
much.
it's kind of what I figured, and so that's why I'm not doing it.
Okay.
But this is just so you'll memorize, how to do the determinant here, and then you'll just simply, to find the inverse, you do 1 over the determinant, so that's going to be like 1 over 7 or 1 over -3. You're going to get a nice number here, right? Okay. And then you're going to scalar multiplication that into this matrix. Okay, so if this was a 2 and this was a 4, they just switch spots, so now the 4 is up here, the 2 is down here. And these B and C values, they just become opposite of whatever they were.
Okay, that's not that bad.
Okay, it's actually pretty easy.
Okay, I forgot about
Okay.
scale multiplication.
Yeah, me too.
Alright? So we'll do one here. It's pretty easy. And I'll show you essentially what happens. Alright? Alright, so we'll let matrix A be 3, 5, -4, -8. The determinant of matrix A will be -24 minus -20. We take this diagonal product minus this diagonal product. So -24 minus -20, and we get -4, right? So now the inverse of matrix A will equal 1 over -4 times, what do the A and D values do? Switch spots. So -8 and 3. And what do the B and C values do? Switch signs. So -5 up here, +4 down here. Now if I just distribute that, -1/4 times -8, +2.
My bad.
It's alright.
Negative.
-1/4 times -5, 5/4. -1/4 times 4 would be -1, and -1/4 times 3 would be -3/4. And you have found the inverse of a 2x2 matrix.
So that's our answer.
It's not that bad.
That, if I said, find the inverse of this matrix, there's your answer. Okay?
But I need to tell you, it's just like this.
Alright, any questions on finding inverses?